Hello and welcome everyone to yet another tech enthusiastic video from Simplilearn. Today we will learn about collections in Java. But before we begin, please be kind enough to get subscribed to our YouTube channel and hit the bell icon so that you can stay updated about the trending technologies in the current industry. Also, if you're looking for online training and certification programs on the latest technologies like data science, machine learning, and artificial intelligence, or to master the cutting-edge programming languages like Java, Python, C#, etc., then please visit the Simplilearn official website to enroll, master, and get certified. Now, without much ado, let us dive into our session. We will start off with the agenda. First, we will learn the basic definition of a Java collection. Followed by that, we will understand the meaning of Java collection framework. After that, we will come across the Java collection hierarchy. After we learn the Java collections interface, we will have a briefing about the Java collection interface methods. Then, up next, we will be in the Java collection classes. Next, we will enter the Java collections APIs, and finally, we will wind up the session by learning the benefits of Java collections. I hope I made myself clear with the agenda. Now, let's quickly dive into our first topic. What exactly is a Java collection? A Java collection can be generally defined as a collective unit of objects in the form of a group. For example, a group of numbers of integer data type, etc. Moving forward, we enter into our next topic where we face the Java collections framework. This will help us understand Java collections in a little more detailed way. A Java collection framework represents a unified architecture for storing and manipulating a group of objects. Its architecture includes the following: an interface, a class, and the Java collections API. To understand these in a much better way, we shall now go through the Java collections hierarchy. The utility package java.util contains all the classes and interfaces that are required by a collection framework. The collection framework contains an interface named as an iterable interface, which provides the iterator to iterate through all the collections. This interface can be extended by the main collection interface, which acts as the root for the collection framework. All the collections extend this collection interface, thereby extending the properties of the iterator and the methods of this interface. The following figure illustrates the hierarchy of collection framework. Out of the complexities, we have the interface and the classes as the major part of the collections. Now, let us understand each one of them at one step at a time. As you can see on the screen, we have the iterable class, which is implemented by the collection class, and this particular collection class is further implemented by list, queue, and set. And moving ahead, we have the following classes which have implemented the list, queue, and set classes. In the list, we have array list, linked list, vector, stack, and on the other hand, on the queue, we have priority queue, dequeue, and array dequeue. And finally, on the set, we have the hash set, linked hash set, sorted set, tree set, etc. Now moving further, we will enter our first Java collection, which is none other than the interface. So the first one is an interface. An interface can have methods and variables, but the methods declared in an interface are by default abstract. That is, only the method signature is available, not the body. Interfaces specify what a class must do and not how it must do. It is a blueprint of a class. Now, a Java collection is a foundation to the Java collections framework. Note that all the collection interfaces are generic. For example, public interface collection is the syntax for the generics, and when we declare the collection, we should use it to specify the type of object which it can contain. It helps in reducing runtime errors by type checking the objects at compile time. To keep the number of core collections interface manageable, the Java platform doesn't provide separate interfaces for each variant of each collection type. If an unsupported operation is invoked, a collection implementation throws an unsupported operation exception. Now, under the collection interface, we have many interfaces that we should use for data manipulation. A few of the major ones are set interface, list interface, dequeue interface, queue interface, map interface, sorted set interface, sorted map interface. Don't worry, those are a lot of interfaces, but we will discuss each one of them in a detailed way along with a practical example for a better understanding. So the first one in the docket is the set interface. A set is a collection that cannot contain any duplicate elements. This interface model is the mathematical set abstraction and is used to represent sets such as a deck of cards. The Java platform contains three general-purpose set implementations: the hash set, tree set, and linked hash set. The set interface does not allow random access to an element in the collection. You can use an iterator for each loop to traverse elements of a set. Now, for a better understanding, let us go through a practical example. I have prepared a code document for all the programs that I am going to explain to just save time. You can always have access to it. All you need to do is just ask for it in the comment section below. So you can see on my screen we have an example for set interface. In this particular example, we are going to store the elements 21, 23, 43, 53, 22, and 65. So let's try to execute this program and see the output. So you can see the elements stored in the set interface are 65, 21, 53, 22, and 23, 43. So the sorted set is here, which is the 21, 22, 23, 43, 53, and 65, and the first element being 21 and the last element being 65. So this is how the set interface practically works. Now let's move ahead into our next type of interface, which is none other than the list interface. So what exactly is a list interface? The list interface is an ordered collection that can contain duplicate elements. You can access any element from its index. The list is more likely an array with dynamic length. The list is one of the most used collection types. An array list and linked list are the implementation classes of the list interface. The list interface provides useful methods to add an element at a specific index, to remove and replace elements based on the index, and to get a sublist using the index. For a better understanding, let's check out an example. So this particular program is based on list interface. So we are going to add in three names, which are David, John, and Stacy, into our list, and also we have a fourth addition, which is Stacy again. Just to check if the statement is true, it says list interface also allows duplicate elements unlike the set interface. So let's try to run this program and see the output. So you can see the program got successfully executed and the names David, John, and Stacy are added into the list. Now let's come back to our program and remove this comment and try to run again and check if the fourth element, which is the duplicate of the third, Stacy, will be added into the list or not. So as you can see, the program got successfully executed and the fourth element, which is Stacy, the duplication of the first one, got successfully inserted into the list. So this is how the list interface works. Now let's move ahead into our next type of interface, which is the queue interface. So what exactly is a queue interface? Queue is a collection used to hold multiple elements prior to processing. Besides basic collection operations, a queue provides additional insertion, extraction, and inspection operations. Queues typically, but do not necessarily, order elements in the FIFO or first in, first out manner. Among the exceptions are priority queues, which order elements according to a supplied comparator, or the elements in natural ordering. Whatever the ordering used, the head of the queue is the element that would be removed by a call to remove or poll. In a first in, first out queue, all new elements are inserted at the tail of the queue. Now for a better understanding, let's go through a practical example. So as you can see, the program on my screen is an example for queue interface. So in this particular queue, we are going to store the names of fruits: apple, mango, grapes, and banana, and apple being the head of the queue and banana being the tail of the queue. Now let's try to execute this program and see the output. So we are also going to count the size of the queue, which is 4 basically in the first. After that we are going to remove the element grapes from the queue. So the command is queue.remove the element name. So after that the grapes element has been removed from our queue. We have the latest size of the queue as 3. Now after that we are also going to check if the element apple is included in the queue or not. So for that statement, yes, the element apple is included in the queue and the result is true. So this is how the queues work, and let's move further. And in the next phase we have the DQ interface. So what exactly is a DQ interface? So a linear collection that supports element insertion and removal at both the ends is called as a DQ interface. The name DQ is short for double-ended queue and is usually pronounced as DEQ. Most DQ implementations place no fixed limits on the number of elements they may contain, but this interface supports capacity-restricted DQs as well as those with no fixed size limit. This interface defines methods to access the elements at both the ends of the DQ. Methods are provided to insert, remove, and examine the element. For a better understanding, let's check out an example. So you can see on my screen we have a program for DQ interface. So here we are going to add in some elements into our DQ and then also try to remove the first element and print the updated DQ. Now let's try to execute this program and see the output. So as you can see, the program got successfully executed and the elements which we tried to push into the DQ were 52, 10 and 21. 52 is being the first element and the 21 is being the last element. So we tried to remove the first element, which is the 52. So after that the updated DQ is having two elements which are 10 and 21. So this is how the queues work. Now let's move ahead and learn our next type of interface, which is the map interface. So what exactly is a map interface? A Java map is an object that maps keys along with its values. A map cannot contain duplicate keys. Each key can map to at most one value. The Java platform contains three general purpose map implementations, which are the hash map, tree map, and linked hash map. The basic operations of a map are contains key, contains value, size, and is empty. For a better understanding, let us check out an example. So this particular example on my screen is an example for map interface. Here we are going to add three elements and map them as 1 as cricket, 2 as hockey, and 3 as archery. Now let us execute this program and see the output. So you can see the program got successfully executed and the elements are mapped with their keys, and the element cricket is mapped with the key 1, and similarly hockey with key 2 and archery with key 3. So this is how the map interfaces work. Now let's move further into our next type of interface, which is the sorted set interface. So what exactly is a sorted set interface? So a sorted set is a set that maintains its elements in ascending order. Several additional operations are provided to take advantage of the ordering. Sorted sets are usually used for naturally ordered sets, such as word lists and membership roles. For a better understanding, let's check out an example based on sorted set interface. So you can see the program on my screen is an example for sorted set interface. So here we are going to add in Bob, Sean, and Jennifer into our set, and we are going to print the same. Let's try to execute this program and see the output. So you can see the program got successfully executed and we have our elements printed in the sorted set, and you can see the names are been arranged in the form of ascending order according to the alphabets which have started in the first position. So this is exactly how the sorted set interface works. So the last one in the interfaces is the sorted map interface, a map that maintains its mapping in an ascending key order. This is the map analog of sorted set. The sorted maps are used for naturally ordered collections of key value pairs such as dictionaries and telephone directories. Now for a better understanding, let's check out an example based on map interface or sorted map interface. So you can see the program on my screen is an example for sorted map interface. So here we are going to add in the elements John, Molly, Aaron and Daisy into the map interface. Now along with the names, we also have their aggregates, which is 76.5 for John, 87.3 for Molly and 78.2 for Aaron. And for Daisy we have 73.4. Now finally we are going to fetch the data of Molly, which is the aggregate of Molly. Now let's try to execute this program and see the output. So you can see the program got successfully executed and Molly's aggregate is 87.3. So this is how the map interfaces work. Now let's move ahead into our next topic, which is the Java collection classes. So now that we have finished the Java collection interfaces, let us have a quick understanding of Java interface methods. So the first method is the add method. The add method is used to add an object to the collection, and next is the isEmpty method. This method returns the true if the collection contains no elements. Followed by that we have the clear method, and this method is used to remove all the elements from the collection. Followed by that we have the remove method. This method is used to remove the given object from the collection. If there are duplicate values, then this method removes the first occurrence of the object. Next to the remove method we have the size method. So the size method is used to return the number of elements in the collection. So after the size method we have the stream method. The stream method is used to return a sequential stream with this collection as its source. So the next method we have is the toArray method. So the toArray method is used to return an array containing all the elements in this collection. Followed by that we have the hashcode method. This method is used to return the hashcode value for this collection. Next, the equals method. The equals method is used to compare the specified object with the remaining elements in the collection. Followed by that we have the iterator method. So the iterator method is used as an iterator over the elements of the particular collection. And finally we have the contains method. So the contains method returns true if a specified element is existing in the collection and false if it is not present. So with this we finish the collection interface and collection interface methods. Now we will move ahead into our next topic, which is none other than the Java collection classes. So what exactly is a class? A class is a user-defined blueprint or prototype from which objects are created. It represents a set of properties or methods that are common to all the objects of one type. Now we'll start up with the first one, which is the hash set class. So the Java hash set is the basic implementation of the set interface that is backed up by the hash map. It makes no guarantee for the iteration order of the set and permits null elements as well. So this class offers constant time performance for basic operations such as add, remove, contains, and size. Assuming the hash function disperses the elements properly among the buckets, we can set the initial capacity and load factor for this collection. The load factor is a measure of how full the hash map is allowed to get before its capacity is automatically increased. For a better understanding, let's go through an example. So on my screen you can see a program which is an example for hash set classes. So inside this we are going to store some names which are the names of the manufacturers of bikes along with null values. So we have added in two null values to just check if it allows two null values at once. So basically it only should allow one null value. So let's check out how does it perform. So you can see the program got successfully executed and the null value is stored only once, that too in the first location. So this is how the hash set classes work. Moving further, we will deal with the next type of class, which is the tree set class. So a tree set class is a navigable set implementation based on a tree map. The elements are ordered using their natural ordering or by a comparator provided at set creation time, depending on which constructor is being used. This implementation provides guaranteed logged time cost for the basic operations such as add, remove, and contains. Note that the ordering maintained by a set, whether or not an explicit comparator is provided, must be consistent with equals if it is to correctly implement the set interface. Now, to understand in a much better way, let us go through an example. Now we are going to add in some numbers into the tree set using the add method. Now let's execute this code and see the output. So you can see the numbers are added into the tree set and the numbers are ordered in ascending order, which is 0, 18, 88, 748, 983, 8476. Now let's move further into our next type of class, which is the array list class. So array list in Java is a resizable array that is an implementation of list interface that allows null elements. So in this class we have three types of arrays, which are one-dimensional arrays, two-dimensional arrays, and three-dimensional arrays. Now let's check out the one-dimensional array. So a one-dimensional array looks similar to this, where we have the array index and the element present in the array. So here our indexes are A0, 1, 2, 3, and 4, and the elements which are shown here. To understand one-dimensional arrays in a much better way, let's go through a sample program. So you can see the program written on my screen is an example for one-dimensional array, and we are going to store the elements 10, 20, and 30 into my array A. So you can see the program has been successfully executed and the elements have been added into my one-dimensional array. Moving further, we will discuss the two-dimensional arrays. The two-dimensional arrays are completely similar to one-dimensional array, but the only difference is the index numbers. Earlier we had index number, but now we have index numbers. Now using these index numbers, we can represent the elements in a matrix form. So to understand this in a much better way, let's go through a sample code. So you can see this particular program in my screen is an example for two-dimensional arrays. So here we are going to add in elements 1, 2, 3, and 4 in the matrix form, and we are going to use two for loops to print that. Now let's execute this program and see the output. So you can see we have the elements 1, 2, 3, and 4, and the elements are printed in the matrix form. At the array index location 0, 0 we have 1, 0, 1 we have 2, and 1, 0 we have 3, and 1, 1 we have 4. So this is how the two-dimensional arrays work. And finally, let's deal with the third type of array, which is the multi-dimensional or three-dimensional array. So you can see the three-dimensional array is completely similar or a little bit similar to the two-dimensional array, but the only difference is we have a third vector here. So next up we have the linked list. Linked lists also come under Java collection classes. There are three types of linked lists, which are single linked list, doubly linked list, and circular linked list. Now let's check out each one of those. So the first one is the singly linked list. So you can see in a singly linked list, each memory segment is divided into two parts. So the first half of the memory location is given for the element, and the second half of the memory location is dedicated for the address. So this particular address is used to point to the next element or the next memory allocation which stores the second element. Similarly, the third. So this is how the singly linked list works. So the last memory allocation is called as the tail, and the last address will not store nothing but null, which indicates the end of the singly linked list. Now to understand singly linked list in a much better way, let's try to execute a sample program. So you can see the program on my screen is an example for singly linked list. Now we are going to add in the elements 1, 2, 3, and 4 in the form of a singly linked list. Now let's try to execute this program and see the output. So you can see the program got successfully executed and the elements are 1, 2, 3, and 4. Now let's move further and try to learn the next type of linked list, which is the doubly linked list. So the doubly linked list is completely similar to that of the singly linked list, but the only difference is we have two address locations. So the first address location of the head stores null and the last address location of the tail stores null, which indicate the start and end of the doubly linked list respectively. So here in the second memory location you have two addresses. So the first address points to the previous element and the next address points to the next element. So to understand doubly linked list in a much better way, let's try to execute a sample program. So as you can see, the program on my screen is an example for doubly linked list, and we have the node which has the data and previous address, next address. Now let's try to execute this program and see the output. And the elements that we are going to store in this particular doubly linked list are 1, 2, 3, 4 and 5. So as you can see, the program got successfully executed and the nodes are 1, 2, 3 and 4 and 5. So this is how the doubly linked list work. And now let's check out the third type of linked list, which is the circular linked list. So there are similarities between the previous linked list and the circular linked list. So the circular linked list makes it circular based on the last address location. So this particular address location points to the first element back again. So this is how it becomes a circular linked list. So to understand this in a much better way, let's check out an example for it. So you can see the program on my screen is an example for circular linked list. Now let's try to execute this and see the output. So you can see we have successfully included 1, 2, 3, 4, 5, 6 and 7 and 8 into our circular linked list, and they are printed on the screen. So this is how the circular linked list work. So moving further, we will try to understand the next type of classes in Java collections, which is the hash map class. So hash table is based on the implementation of map interface. This implementation provides all the optional map operations and permits null values and the null key. Hash map class is roughly equivalent to hash table, except that it is unsynchronized and permits null. This class makes no guarantee for the order of the map. Now for a better understanding, let's go through a sample program. So this particular program on my screen is an example for hash map class. So here we are trying to load the data, which is the name of the manufacturer and their bike. So let's execute this program and see the output. So you can see the program got successfully executed and we have the manufacturer and their made bikes. Now moving further, we will deal with the next type of class in Java collection, which is the tree map class. So the tree map is based on navigable map implementation. The map is sorted according to the natural ordering of its keys or by a comparator provided at map creation time depending on the constructor used. Now let's check out an example for better understanding. So you can see the program written on my screen is an example for tree map class. So we have the roll numbers and the names of students here. Now let's try to execute this program and see the output. So the program got successfully executed and the result has been printed on the output console. So we have the roll numbers of the students and their names: Amber, James, Violet and Reynolds, along with their respective IDs. So now with this, we complete the Java collections classes. Now we move into our next topic, which is the collection API algorithms. So the first one is sorting. Sorting does the job of ascending and descending numbers based on the algorithm written by the user. For a simple example, we shall consider the bubble sort algorithm for this one. So you can see on my screen we have an example for bubble sort algorithm. So we have the elements 2, 89, 39, 48, 6, 28, 1, 2 and 33, which are ordered in a unorderly manner. Let's try to execute this program and order them. So you can see array before bubble sort is 289, 38, 48, similarly 33, and after the bubble sort we have the sorted array, which is 1, 2, 6, 28, 33, 39, 48 and 289. So this is how the bubble sort works. Now let's move further and understand the next type of API, which is the shuffling algorithm. So the shuffling algorithms are designed to destroy the current arrangements. They are employed on creating randomness in the list. So for a better understanding, let's check out an example. So you can see the program written on my screen is an example for shuffle algorithm. So we have an array which has the elements completely sorted in ascending order, which is 10 to 100. Now when we run the shuffle algorithm, these elements will be completely shuffled according to a random order. Now let's try to execute this program and see the output. So you can see the elements which were in an ascending order are now completely in disorder. So this is how the shuffling algorithm works. Now let's move further and understand the next type of algorithm, which is the searching algorithm. Searching algorithm is employed to search an element in the list or array based on the type of searching mechanism used. Now for example, let's use the binary search. Now you can see a program on my screen which is an example for binary search. So we have the elements 1, 2, 3, 4 and 5 in our array. Now what we are going to do is search for the element or the key element 2 in our array using the binary search algorithm. Now let's execute this program and see the output. Now you can see the program got successfully executed and the output says the element which you are looking for is found in the index location 1. So this is how the binary search algorithm works. Now let's move further and understand the next type of algorithm, which is the composition algorithm. So the definition says the frequency and disjoint algorithms test some aspect of composition of one or more collections. So the frequency counts the number of times the specified element occurs in the specified collection. So the disjoint determines whether two collections are disjoint, that is whether they contain no element in common or not. Now to understand it in a much better way, let's go through an example. So you can see on my screen there is an example for composition. Now let's run this program and see the output. So you can see the program got successfully executed and the elements are completely disjoint. Now moving further, we will enter into our next topic, which is based on the benefits of Java collections. So there are various benefits of Java collections. Out of those, the major benefits are software or code reusability. So the Java collections enable code reusability to save time. Followed by that, the ease of designing APIs. So the next two ease of designing APIs, we have the simplicity in learning and using APIs, and finally increased speed in programming. So these were the major benefits of Java collections. So with this, we have come to an end of this session. I hope this was resourceful, and if you have any queries regarding this session, then please feel free to drop them down in the comment section below. Also, don't forget to subscribe the Simplilearn YouTube channel and hit the bell icon to stay connected to us and get important updates based on the current IT. This is Ravi signing off. Thank you. Until next time.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.